Greetings to you all. Today I'll be doing the concepts of electric circuits with you, where I will be putting in comparison the series circuits together with the parallel circuits. So we'll start with the series circuit. Remember, we're doing the concept of electric circuits. So now, in electric circuits we have parallel and series circuits. Okay. Those are the connections, the two types of connections that we can have. So we will start with the series connection. I'll just draw a circuit at random. Okay. Then we're gonna have, okay, I'll put the resistor one here. This is a resistor one. Then I'll call this one I total current, and then I'll call this one, okay, this one I1. And then this one I2, then I introduce a resistor also here, then a resistor also here. I'll call it resistor 3. This will be resistor 2. Then we will have I3 here, okay, I3 for current. Then we connect the voltmeters. You connect the voltmeters, which are always connected parallel to the resistors. Okay, so now we have our series circuit here. So now in a series circuit, all charges pass through the same points or similar points through every component. So now, okay, that's about the current. We said it passes through same points. That's energy flow, or the flow of charges. They move through each and every component. So now, if they move through each and every component, it means that current remains the same throughout the entire circuit, which simply means that the I total will be equal to I1, will be equal to I2, and automatically will be equal to the I3. Okay? Remember that I is equal to V over R. R, which is the resistance. How do we calculate the resistance in series circuits? So now, in a series circuit, we simply add the sum of all the resistors added in a circuit will give us the total resistance. That's the total resistance is equal to the sum of all resistors connected in a circuit. Okay? This simply means that R total is equal to R1 plus R2 plus R3. This will be the formula for calculating the total resistance of a circuit. And bear in mind that if you add more resistors here, it will increase the total resistance of the circuit. Adding more resistors increases the total resistance. And thus current will decrease. We are now saying that if resistance increases, this is the resistance increasing. automatically the current will reduce. That's what we are saying. So now, if you connect more bulbs in a series circuit, that the resistance will increase. This resistance, it will increase. As it increases, it will reduce the flow of current, and automatically this will result in the less energy use, and the battery will not last longer. So now we're going to straight move to the parallel circuit. I'm gonna erase all of these things. I'm gonna paste the picture of the notes that are nicely drafted at the end of this video. It's gonna be there and paused for 15 seconds. When you get there, you just pause, and then you feel free to copy everything. They are nicely drafted and clearly showing that we are comparing series circuits with the parallel circuit. So now we will do the parallel connections. Parallel circuit. I will quickly draw a circuit here. Okay. This will be our I total, and then we will have a branch. This will be R1, and then we'll have I1 also here. Then we connect the voltmeter. Okay. We go down again. This will be our I2. Then we connect the resistor. It's going to be resistor 2. Then together with the voltmeter. Each and every resistor goes with the voltmeter. Then we're also going to have the last one. This will be I3. Then we connect the resistor. We're going to call it resistor 3 with the voltmeter. Then boom, done. We are done like this. So now in a parallel circuit, charges pass through different points. And this only happens because the parallel circuit acts like the current or charges divider. It divides the current. As you can see, at this intersection, we would have other current going this side and the other that side. Then automatically also the other current will go that side, then the other one will go this side. That's charges pass through different points. The charges passing by resistor 1 and not the very same charges that will pass by resistor 3. Does it make sense? So now, in a parallel circuit, the current splits into different pathways. The current splits into different pathways. I've tried to show you how does that happen. And now the total current of the entire circuit will be calculated by adding the sum of all the currents across this circuit. So which is for the current, I total will be equal to I1 plus I2 plus I3. That's how you will get the current for the entire circuit in a parallel connection. Does it make sense? Now bear in mind that I is equal to V over I. So now, how can you calculate current passing by resistor 1? You're going to make use of this formula. I1, this is I1, is going to be equal to the voltages across the entire circuit divided by how many? You're just going to say R1, the resistance 1. How can you calculate the current passing by resistor 2? You're just going to do the same thing, okay, and say I2 is equal to V over R2. Same applies to the current passing by resistor 3. Now I can see that you're following and everything is simple for you. So now, how do we calculate the resistance in a parallel connection? Hey, come with me. We just add and find the inverse of our sum. That's the resistance. It's going to be calculated by using this formula. 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Can you see that? This is simple, but when we have only two resistors connected, you can use this formula to say RT is equal to R1 multiplied by R2, R1 multiplied by R2 divided by R1 plus R2. That's the derived formula, but it will only be applicable when you have strictly two resistors. I don't know about 3, but I'm still going to explore it also. But to play safe, you just make use of this one, and this one can be derived into R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. All of this in brackets to the power of -1. Then that's when we will get the correct answer for the total resistance of the entire circuit. Thank you very much. I believe that you're going to learn a lot. So I'll make sure that I add the notes, and here are the notes. I'm going to pause for 15 minutes so that you can copy everything. They are nicely compared to one another for series circuits and parallel circuits. In a series circuit, all charges flow through the same pathway and through every component, whereas in a parallel circuit, all charges pass through different points. That current in the series circuit, it remains the same, whereas for a parallel circuit we're going to have current passing by different points because we have branches, you can see. Yes, then you will go through the rest on the paper. Thank you very much. Feel free to text me on 076 592 4017. That's my WhatsApp number. Again, 076 592 4017 for queries. Remember that queries are for free. We can never make you pay for education. We just want to benefit your mind so that it becomes well capacitated in terms of physical sciences. Remember, you're more than welcome to ask anything that has got to do with physical sciences grade 10, 11, and 12. And for more videos, subscribe to Untitled Essay on YouTube. Untitled Essay on YouTube. I'll make sure that I post content each and every day. Shout out to you. Bye. Remember to subscribe and turn on the notifications button. Share the videos with your close friends, families, relatives so that they can also learn. I love you guys. This is Untitled Essay for you. Thank you. Bye.